second problem in the gravity and uniform circular motion worksheet that you have. This problem is a car going 32 meters per second rounds a curve with a 56 meter radius. We're going to find the car's centripetal acceleration, and we're going to find the minimum coefficient of static friction required between the tires and the road before the car would start to slide. First thing, we drew the picture. So I have an overhead view where you can see the friction is clearly the force going towards the center of the circle, so that's our centripetal force. Here's a view as if we were the car behind this one around the turn, and you can see gravity pulls down, the normal pushes up, and friction still going in towards the center of the turn. The velocity of the car is 32 meters per second, and the radius is 56 meters, and here the acceleration and coefficient are the things we're trying to find. First thing we're going to do is try and find the acceleration. We have an equation for that, which is given by v squared over r. We have both of those numbers, so we can solve for the acceleration rather easily. And we just have to plug in our 32 meters per second. We square that divided by a radius of 56 meters. And when we plug in the numbers into our calculator, we should get an acceleration of 18.3 meters per second squared. So that's our first answer. The next one is finding the coefficient. This one is a little trickier. First thing we know is that the force of friction is equal to the centripetal force. So anything we can say about the centripetal force, any equation we have for that, we can use to also describe the force of friction. But we already have an equation which describes friction, and that's the coefficient multiplied by the normal force. And since we have the acceleration, it would probably be easiest to just use m times a for the centripetal force. Now, the only thing that we don't really know what to do with right now is the normal force. We don't have mass, but that doesn't break down into anything else, but we do know some stuff about the normal force. The normal force is upward, and the force of gravity is downward, so we know that those two things have to be equal to each other. And since we know that they're equal to each other, instead of normal force, I can write mass times 9.8, which is weight, and the right side of the equation remains unchanged. From here, hopefully everybody can see that the masses will cancel, leaving me with the coefficient times gravity equals the acceleration of the car. All we have to do is divide by the gravity, and we can get our coefficient. So that equation would look like this: acceleration divided by g, which is 9.8. We can plug in our numbers, and the acceleration was 18.3 meters per second squared. Gravity here on Earth is always 9.8 meters per second squared. And when we divide those two numbers, we find that the coefficient has to be at least 1.87 in order for the car not to slide while going around the turn.